Hi there! Today we're going to be looking at lesson 4.2b, which still we are going to be identifying and representing linear functions using tables, equations, and graphs. You might need your calculator for this one. I know we'll be kind of doing it together here. So let's just review what we talked about yesterday. Our vocab words here, a function, which is the same thing as an equation, but a function is a relationship between two variables, the independent variable and the dependent variable. So here we have a table, and this is our hourly wage, so we can see how many hours we work and how much we're going to get paid. So think about what depends on what. Which one's our dependent variable? You see our pay is going to depend on how many hours we work. So because our pay depends on our hours, our pay is our dependent variable. So I'm going to write dependent in here. You can do it too. Which means then that the hours is our independent variable. Now notice I circled the part that says in. The independent variable is also our inputs, and our inputs are always our x values. I could put in any value for x that I want, and then I could figure out how much money I would get paid. Okay, so let's take these points and graph them to figure out what this graph will look like. Well, it looks like if I work no hours, I get no pay. That makes sense. 4 hours, $42. Or for 4, and then just got to guess a little bit past 40 be 42. 6 hours, $63. Probably between 40 and 80 here. Got to estimate it. 18. Oh, all the way over to 18 and up to 189. Be close to the 200. These numbers are a little off right here, so 18. The 200 is actually this line right here. Be careful when you're graphing that. A little bit less than that. So do the best you can. We can see that this is going to be linear. Now let's write a function rule for it. All right, so taking a look at our table, we want to figure out our function rule. Now, just by looking across here, you may not be able to see exactly what you multiply by. So we could figure out our pattern, our y over our x. You can pick any 2 points. I could use the 63 to 189. I could use this. Just, you got to pick 2 points. So from 0 to 42, add 42. 0 to 4 would be adding 4. And so our y over x pattern is 42 over 4. Let's see if we can change it to a decimal so this makes a little bit more sense. So if I take my calculator and I type in 42 divided by 4, 10.5. All right, 10.5, there's my magic number. That's my pattern here. So y equals 10.5x. There's my number here, my y over x pattern. Now let's check and see, does that actually get you across the table? So if I take 4 and multiply it by 10.5, will I get 42? And so I'm just going to try that here. You always want to check to see if this works. So if I take 4 and multiply it by 10.5, yes, in fact, I do get 42. Perfect. So it got me across the table. It should, because if you think this second number is when x is 0, and when x is 0, y is also 0. So this would be 10.5x plus 0. So this one's looks like we're making $10.5 or $10.50 for every hour we work. All right, so there's our first one. Let's look at our next example. Here we have a leak in a tank. Well, that doesn't sound good. Let's first label what our independent and our dependent variables are. So here we have the time going by, and this is how many gallons of water is in the tank. Well, doesn't it make sense that the amount of gallons of water in the tank would depend on how much time goes by? Yeah, I think so. Remember, the x values are your independent because they are your inputs, and the y values are your dependent variables. So time is our independent, and gallons is our dependent. You want to jot those down in your notes. It makes sense that the amount of gallons in the tank would depend on how much time has gone by. And, you know, of course, it's leaking out. So let's take these ordered pairs. We're just going to graph them on the coordinate plane here. So looks like we've got time of 1, so maybe 1 hour goes by. And we have 12 gallons. 3 hours go by, and we have 6 gallons. 4 hours goes by, 3 gallons. 5 hours goes by, 0 gallons. So it looks like after 5 hours, the tank completely emptied. And here you can see that this makes a straight line. All right, let's write the equation. So I'm going to get my blanks ready. Y equals... All right. So I am ready. This is going to be my y over x pattern. So y, looks like we're going down 6, over x, we're going up 2. So y over x. Y is down 6, x is positive 2, negative 6 divided by 2, negative 3. So that number goes right here. All right, so now I have to figure out when is x 0? Where does this function start? Well, looking at the graph, when x is 0, can you go all the way up here and see the point here would be at 15? Same thing here. If I go back to 0 and go across, so that means I'm going back up here to 0, which means I would go back up here and then have to add 3, which is going to give me 15. But you can see from the graph here, that's going to be 15 as well. So just try a point. I mean, I always like to try a point. So to get y, I take x times negative 3 and add 15. So here, I'll take this number, my x, multiply it by negative 3. Oh, that would give me negative 12. And then if I add 15, does that get me across the table to the 3? Absolutely does. There's our equation. All right. Next one here. Here we have fuel being used and distance that we're maybe traveling. So amount of gas we're using and how far we're going. Well, it makes sense that as the amount of gas we use increases, the further we're going to go. So, independent, dependent again. You kind of got this. The distance that we travel is going to depend on how much fuel we have. So, of course, this is going to be our dependent. Your y is always your dependent. And your x is your independent because it's your input. And there's my x. Okay. So this time we have a graph, and we have some points on the graph, and maybe we want to just take those points here and fill them in the table. Once we take the points and put them in the table, it's going to be a lot easier to write the equation when we have this table. So if you look at your line, there we go, there's a point right here. That's 0, 0. And then over 1 up 20. X is 1, y is 20. Over 2 up 40. Over 3 up 60. And I could keep going, but I really don't have to. So now let's just go ahead and write the equation for this. All right. Ooh, in fact, you might be able to just look straight across the table and see what you're multiplying by. Yeah, you should be able to. All right, let's look at our y over x pattern. Looks like we're going up 20, going up 1. So y over x, that simplifies to 20. So y equals, my first number is going to be 20 times x. Now remember, the second number is when x equals 0. But look here, when x equals 0, y is 0. So that would just be a 0. Well, let's try it. To get y, take 20 times x. Is that true? Do I multiply the x value by 20 to get y? X value times 20? Sure do. And there we go. We can see that that's that 0, 0. So we have that, just a number in this first box here. All right, let's look at the next one. Ooh. So here we're going to be representing the relationship between the number of rectangles and the perimeter. So a little geometry connection here. So number of rectangles and perimeter. Well, our perimeter is going to depend on how many rectangles we have. So because our perimeter depends on this, our perimeter is the dependent. So that's my y. And the number of rectangles, that's my x. So here I can make a table. So let's take a look. We have 1, 2, 3, 4 rectangles. 1, 2, 3, 4. Let's figure out the perimeter. So I'm just adding up the sides. 1 plus 6 plus 1 plus 6. And you can go ahead and just find the perimeter of each one of these and then just fill in your table there. All right, hopefully your table looks just like mine. Now let's graph it. 114 over 1 up about 14, 2, 16, 3, 18, and 4, 20. So we can see that all of these points lie in a straight line. All right, so let's go ahead and write our equation. I need my y over x pattern. So looks like we're going up 2, up 1. So 2 over 1, y over x is 2 over 1, which is 2. So there's my 2 there. So it looks like so far to get y, I take x times 2. All right, so here's my x. If I multiply it by 2, that's 6. Well, what do I still need to add to get across here? Yeah, 12, right? Same thing here. If I multiply this by 2, I get 8. But I still need to add 12. So you might be thinking, oh, I got to add 12. 12 goes here. Well, it's true. In fact, if I were to draw the line through here, I can see that when x is 0, y is 12. But I also can go back up here to when x is 0, and then go back up the pattern. So minus 2, go all the way back up here, and we see that this is 12. When x is 0, y is 12. So there we go. There's our equation. Second one here, we have the same type of thing. So we're going to represent the relationship between the number of shapes and the perimeter that they form. Looks like these are pentagons. So number of shapes and perimeter. So again, the perimeter is going to depend on how many shapes. So here we have perimeter, and here we have the number of shapes. All right, so number of shapes 1, here we have 2 shapes, and here we have 1, 2, 3 shapes, or 3 pentagons. So again, you just want to add up the perimeter, add up all the outsides here, and clearly you can see that that's 5. And then here, if I go around, 1, 2, 3, 4, 5, 6, 7, 8. And then again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so we can see here that this is increasing by 3 each time, right? All right, let's graph it. So 1 pentagon, perimeter of 5, about here. 2 pentagons, perimeter of 8, about here. 3 pentagons, about 11. And you can see then, of course, that that's linear. So let's go ahead and write our equation. So it might be kind of hard to look across the table here, so let's use the y over x pattern. Looks like we're going up 3, up 1, so y over x, 3 over 1, and that simplifies to 3. So there's my number there. Now, that's not going to work to get me across the table yet, because if I take 3 times x, I'm not going to get y. Because here, take 3 times this number, that's 9, and that's not going to get me here. So if I first multiply 3 by x, I get 9 here, and then I still have to add 2. Same thing here. This is my x value. If I multiply it by 3, I get 6, and then I have to add 2. So really, I have to add 2 onto this. Well, remember, this is when x is 0. So if I go back up 1 when x is 0, and go back up in my pattern, right, I'd have to go 3 more above this, and that would be 2. So we can see here, yeah, it makes sense that this would be 2. And that does work. Take x times 3 and add 2. And so if I were to connect the points here, I could see here when x is 0, y is about 2 right there. It's kind of hard to see that, but that's what it would look like. All right, next one. This one might look the same, but it's asking us a little different question. Here it's asking us to represent the relationship between the number of vertices in each polygon and the number of isosceles triangles. So the number of isosceles triangles that this is going to make is going to depend on how many vertices. So here I have isosceles triangles. I'm just going to go tri for triangle. That's my dependent variable. And the number of vertices, I'm just going to kind of abbreviate like that. Okay, a vertice, or vertices, that means a vertex, a corner. You might remember that from 6th grade. So the number of vertices on here, I'd have 1, 2, 3, 4, 5 corners. Okay, and now how many isosceles triangles does it make? Well, here is an isosceles triangle. These two sides are the same length, this one's different. So I have 1, 2, 3, 4 triangles. Then the next polygon, I've got 1, 2, 3, 4, 5, 6 vertices, or 6 corners. Now how many triangles does it make? Well, if you look at the triangles here, I got 1, 2, 3, 4, 5. Can you see that the number of triangles is 1 less than how many vertices it has? Let's try this one. So here I got 1, 2, 3, 4, 5, 6, and 1 more in the middle. 7, 7, vertices. And if I look at how many triangles it makes 6. So again, that pattern's consistent. It's one less each time. Well, let's graph it. And let's see how this actually looks on the graph. It should be a linear relationship. So 5, 4, 6, 5, and over 7 up 6. We see that it's a straight line, right? Okay, if I connected, it would be a straight line anyways. All right, let's write the function rule for it. So I can see we're subtracting 1 each time, but we need our function rule to look like this. So I want to take x and subtract 1. All right, so let's look at our y over x pattern. Remember, this is x, this is y. So it looks like we're going up 1, but then here we're going, oh, yeah, we're going up 1. And then here we're also going up 1. Okay, well, y over x would be 1 over 1, which is just, 1. So that's going to be right here. There's my 1. Now, of course, I can't just multiply x by 1 and get across the table. What do I have to do then? So if I take this x multiplied by 1, I'd have to subtract 1. Take this multiplied by 1, subtract 1, right? So I can see here that after I multiply by 1, I have to subtract or take away 1. Now, if this is take away 1, that means that when x is 0, y should be negative 1. So let's go back up to 0. This is going to kind of be funky. So I'm going to go back up 4, 3, 2, 1, 0, all the way back up to when x is 0. So 7, 6, 5, 4, 3, 2, 1, 0. See that? Now I'm going to go back up this way. 6, 5, 4, across from 4 will be 3, 2, 1, 0, and then one more, negative 1. See how that works? So I can see that my rule is to get y, I take x and multiply it by 1. I don't really need the 1 there, though. And then I subtract 1. So this would be my function rule for this relationship. All right, last one. This one, we'll see. Do we need to use our calculator? I'm not sure. Here we have an electric car. Wouldn't that be cool to have one of those? An automaker produces a car that can travel 40 miles on its charged battery. So you can go 40 miles without using any gas, just on a charged battery, okay, before it begins to use the gas. Then the car travels 50 miles for each gallon of gas that's used. Can you imagine getting 50 miles out of 1 gallon of gas? That's incredible gas mileage. So let's represent the relationship between the amount of gas used and the distance traveled. So we have amount of gas and we have distance. Well, the distance is going to depend on how much gas we use. So distance is dependent. That's our y. And our gas is our independent. That's our x. So here I have my table. All right, so let's start this situation off with gas of 0, because we don't have to use any gas and we can still go a distance. Remember, it says we can travel 40 miles on just the charged battery before it uses any gas? So we could use 0 gallons of gas and still go 40 miles. All right? Now, what happens after I use 1 gallon of gas? So think about, I use 1 gallon of gas. It says that for each, it says here that I can travel 50 miles for each gallon of gas. But if I use 1 gallon of gas, am I just going 50 miles? No. If I use 1 gallon of gas, I go 50 miles, but I also go 40 miles. Because remember, the first 40 miles was on the battery, right? So after using 1 gallon of gas, I went 40 miles on the battery plus the 50 miles on that 1 gallon of gas. So this is going to be 90 miles. Okay, so this one takes a little bit of thinking. So let's go 2 gallons. Now, remember, each gallon I travel 50 miles. So that's 50 plus another 50 for those 2 gallons of gas. But then I also have to add on that even though I'm using 2 gallons of gas, I was still able to go 40 miles before I used any gas at all. So if I add all those up, yep, that's 140. So now, you take a guess here. What if I use 3 gallons of gas? So 3 gallons of gas, that's 50 miles, 50 miles, 50 miles, plus the 40 miles that I used for the battery. If I add all this up, I have can't add today, 190. Okay, so now I can take a look and see if I can write a function rule. Oh, wait a minute, we got to get a graph. Okay, graph before function rule. So 0 gallons of gas, right here, I go 40 miles, about right here. 1 gallon of gas, 90. 2 gallons of gas, 140. 3 gallons of gas, 190. Do you see how linear that is? How cool, because it's very consistent. So let's figure out what that consistent change is, our y over x pattern. Up 50, up 1, so y over x is 50 over 1. Makes sense. There's my 50, right? That's my 50 miles every gallon. My gallons go up by 1, my miles go up by 50, right? 50 gallons per mile. Okay, so is this going to get me across the table, though? To get y, do I just take 50 times x? So do I just take this x and multiply by 50? Of course not. No. Remember, this is when x is 0. I have to add this number on. We'll go find 0 when x is 0, 40. So 40 right here, that's where my function starts. So let's try this. Let's see if this actually works. So if I take x, multiply it by 50, and add 40, will it get me across the table to y? So here, if I take this x value, multiply it by 50, that's 0, add 40, that works. What about this? If I multiply this by 50, right here, I get 50, and then if I add 40, do I get 90? Absolutely. It's going to work for everyone. Here, if I multiply this 2 by 50, that's going to give me 100, and if I add 40, do you see how it's going to get me the 140? You always just want to double check your function rule. So this is the function rule that describes the situation. Now notice here, we first start with 40 miles, right? That's how much that's how far we're going on just the battery. And then this is 50 miles per gallon of gas. So it makes perfect sense. All right, well, thank you so much, and hope you enjoyed, and have a great day.